Hey Oakham students, Ben Asman here. Today we're going to do my very favorite purification method, recrystallization. Let's get to it. Okay, recrystallization. How does it work? So, what we're going to have here is we pick a recrystallizing liquid, a solvent, that is going to be soluble for our impurity but not for our product. Ideally, now we have here our table here to exemplify this. Each one of these represents a saturation point at different temperatures. So ideally, we pick a solvent that is way more soluble for our impurity, that's what we have here in orange, over our product. And then we heat it up, and anytime you heat up any solution, just like when you heat up a tea, you can dissolve more stuff in it. Like, for instance, dissolving sugar in cold tea, you're not going to get much sugar into it, but hot tea, you're going to get plenty into it. So once we heat it up, all of our compound goes into solution. That allows us to get any impurities which are trapped between crystals of our compound. But all of our compound goes in solution as well as all of our impurity. And then we slowly cool it down to room temp, at which point our product will precipitate out as a pure product, and ideally our impurity stays into solution. And then we put it into an ice bath, and we and we get just that little bit more out. So essentially, all of this compound here that's missing, all of that is precipitate. So all of this here, that's all precipitate that comes out as a solid. And then here, we get just a little bit more. Now, we still end up that some of it stays in solution. No matter what you do, you will always get some of it stays in solution. So if you add too much solvent, you increase the amount here. Obviously, the more solvent you have, the more tea you have, the more sugar you can dissolve in it. So once we increase the solvent, so we want to use the minimum amount so then not to increase the solvent and get, at the very end, the most amount out and leave the least amount in solution. Anytime you do any kind of purification, you're always trading purity for yield. In this case, that's where it stays in solution. You lose a little bit of it. Now, the important thing to remember for this is that for this step, for the cooling step, the slower you cool it, the bigger your crystals, the purer your product. This is very important. If you cool it too suddenly, you get a lot of really small crystals, which will be less pure. And there is an asterisk here. You can cool this way too slowly, like if you use a machine and you take it over 2 weeks. But that's neither here nor there. But for as far as our case, the slower you cool it, the bigger the crystals, the purer the product. The reason why is this. If you cool it quickly, so that's this one, the entire solution becomes cold enough for it to crystallize at once. And you get plenty of little crystals on here. But if you cool it slowly, what ends up happening is the outside cools first. So we have here, we have a cool zone, and the inside is still hot, so that's our hot zone. And in between, we get a less cool zone. That's where I used to hang out in high school. And now, when you have this kind of situation, the cool zone is cool enough to crystallize already, and so you can see we have some crystals there. But the less cool zone is not quite cool enough to crystallize normally, but because there is some crystals there, if it builds onto an existing crystal, that is actually easier and does not require it to be as cool for that to happen, and thus you grow your crystal and you get a bigger crystal. So that explains slower cooling equals bigger crystals. But how does bigger crystals equal purer product? Well, if you imagine here an individual crystal, obviously nothing is an individual crystal of a single molecule, but and it's all 3D, not 2D. But for my 2D simplified example, this is a single crystal with my impurities on the outside. In general, impurities adsorb with a D, not absorb with a B. Adsorb is inside, adsorb with a D is on the outside, on the surface. Impurities adsorb. So we have our 4 impurities adsorbed. Now, if we have 100 of these crystals, that's 4 impurities times 100 crystals, that's 400 impurities. However, if we have a crystal, which is 10 by 10 across, it's 100 crystals, a single crystal of 100, that would give us 10 impurities on each side here, so that's 10 times 4 sides here, we get 40 impurities. So just by going from a crystal of 1 to a crystal of 100, we improve our purity tenfold, from 400 down to 40. Now, in reality, you're not going from a crystal of 1 to 100, you're going from a crystal of a couple thousand to a crystal of a couple million, billion moles, 10 to the 23rd, depending on how big you grow it. Some of these, you can grow crystals big enough that you can see it. There's some fun things to do with sugar that will do that. You can check YouTube for all of those things. Maybe I'll put one somewhere on the screen as well. But in general, the slower you cool, the bigger the crystal, the purer the product, and you want to use the minimum amount of solvent because you never get all of it back. The more solvent you use, the less you get back. Okay, now how do you actually do it? Okay, we're going to need a Ellemeyer, it's 50 right there, and you're going to need your acetanilide. Make sure it's the impure stuff. It says 333. If it says 334, you got the wrong one. If you try and use that one, you're going to have a weird time. So grab some of this, zero this out, and now we're shooting for plus or minus a gram. This does not have to be dead on exact. All that matters is that you record how much you took. So let's see. There we go, that's close enough for me. And make sure you record this inside your manual. By the way, this is what it looks like up close and personal. Now, as this is your first time working with this kind of thing, this is ideally what it should look like. One, a little bit of foil here that will keep your surface clean. Foil on your sand bath, and your sand bath should be about half filled here, and it should be relatively fine sand. If it's too coarse, you have to sift it. Now next, we do want to, as it's the first time working with these, you want to look at these kind of clamps. We're going to need 2 of these for today. One of these will be for the thermometer, and the other one will be for the actual flask. So that's one thing. Next is we are going to need one of these. This is a rubber thermometer adapter. This is for the thermometer, so we can connect that. This prevents it from slipping, going too far down, and gets it to the correct depth. You're going to start off this way too high up. You always start way too high up when it comes to the thermometer. That way you can attach this, and we want to make sure that all 3 prongs are on and it is as tight as you can make it so far that it's stable, and then you can rotate so that you can see this, and you can rotate so it's the correct angle for you. And now lower it in the sand bath. You want it just above the layer of the sand. Now we'll wait for that in a bit. The next thing we're going to need is our actual flask. Here's our flask. We're going to want to stick that as deep in the sand bed as we can. If your sand is too coarse, you're going to have a hard time doing that. You want to do it just like this. Now, the sand is honestly strong enough to hold this. If you choose to do it without the sand bath, which you can for today, you're going to do it like that. But in that case, I do insist that you add a second clamp to make sure it does not fall away. So once again, I'm going to start off with this here. I'm going to start with that there. Now, make sure that you don't put these on the same rung of the thing. So this is one rung, that's another rung. If you put them on the same rung, you're going to have a hard time maneuvering them if there's an issue. If there's ever an emergency, you want to be able to lift it from here without having to do this. And you want all of these as tight as can be so that it can hold completely without you having to worry about it. Speaking of which, you also want to check these to make sure that they're fine. And if you also don't like the position, you can feel free to move one of them so you can easily have connections to whatever you want. But once you have here and you're satisfied that this is there, we can now first tighten it in position. Once it's tight and you're willing to bet your grade that you got it right, then you can do that. Now in that case, if we're doing it this way, we don't necessarily need the thermometer, but the traditional way that they want it done is with the sand bath. So we're going to show this with the sand bath here as well. And take that and just kind of wiggle that as deep in the sand bath as you can. And there it is. Now, this is not strictly required, but I recommend a boiling chip. Just one is enough. You just pour one out. 1, 2 will be plenty. You don't have to worry about too much, but make sure you fish them out before you're done. Okay, and now we're going to lower our thermometer into the sand. That's about good. We want to just have it. That's a little too high. We want a little lower. Right there, you can just see the tip of that triangle. That's it. Now, it's just to start off with 10 mils of water. 10 mils, an estimate's good enough. I'm going to just literally add to about 10 mils here. There we go. That's 10 mils of water. And now we can start our heating. And we can make sure that this doesn't go above boiling. Now, ideally, you want to have your bath heating ahead of time. I didn't in this case, but it will be fine. Just take a little longer. So now you just have some DI water here. You can just see that it's starting to boil there. If we didn't have the boiling chips, there would be no nucleation points, and that would be harder to see. If we look in from the top, you can see that our acetanilide has melted. Whoop. Our acetanilide has melted, and of course there's some steam coming out. And there's little droplets in there. So now we're at a boil, and it's not fully dissolved, so we have to add some more. It says 0.5, in reality just add some. Are those oil droplets dissolved? More of them are, but they're not fully dissolved yet, so we bring it back up to a boil. Okay, let's take another look. Our droplets fully dissolved. On the face of it, it looks like it. In reality, we might have to pull this out, take a look. I don't see any there. Oh, there is a little bit, those little black dots. So, see those little black dots? I'll add a little bit more water. You don't want to overdo it here. and stick that back on. Nope. Nope. And nope, looks clean. So we're just gonna leave that like that to cool down, and we're gonna turn off the heat. Okay. Okay, pull that away, get that away, and now we're just leaving this suspended to cool down. Now if your tongues are clean, you can just fish out the boiling point, the boiling chip at this point. As you see here, that's our boiling chip. Fished out. Now when you have this, you need this to come to room temperature. The only way to really know is to literally touch it. In this case it's still quite warm, so we'll let it continue coming to room temperature. Remember, the slower you cool it, the bigger the crystals, the purer your product. Okay, while we're waiting for that to finish, we can do a little bit more. We are going to need to set up a filter station. So we have two options. This is a Hirsch funnel. It's ceramic, it's small, and this is a Buckner funnel. It is plastic. It comes in two pieces, a top and a bottom, and it is large. Small funnel gets small filter flask. Big funnel gets big filter flask. Simple enough. In this case, I am guessing by the amount that we're getting that we will need the big ones. So we'll take these, and we will take that and mount it. Now when you mount these, you always want to once again mount it so firm that you don't have to worry about it. So that would be this. And then I like to lower it so it's on the thing, so it's a little easier. And then this should fit in there nice and snug. Then we have two different kinds of tubes. We have latex tubing. This is not good, this will collapse. And we have rubber tubing. This is the good one. That's the one you want to connect to the vacuum right here. And we're going to connect that over here as well. Okay, nice and tight. Now what always goes into this is some filter paper. There's a variety of different sizes of filter paper. You want to find the exact right filter paper that fits into your flask exactly. No folding, no bending, just perfectly in. And we'll use that later. So assuming that's room temperature, we're going to need a flask. I recommend a 250. We're going to want to fill it about halfway with ice. And then top that off with some DI water, because this is an ice bath. It's taking forever. Okay. There we go, that's our ice bath. Pretty cool. And we can kind of see we do have some nice large crystals that have grown already. Okay, it's not quite room temperature, but it is just about. Now we can take our flask we have here, stick that in there, probably another 10 minutes or so until it is nice and ice cold. And we also need to filter this later, so we'll take another container, fill it up about halfway with ice, top it off with some water, and now take a couple test tubes, fill them with water as well, because we'll need that for later, and stick that in the ice. We do not want to use the ice directly because it is not as clean as the DI water. Now you can see here we do have quite a lot of crystallization, but you can see there's still some impurities there on the bottom. It is also ice cold to the touch. So we turn on the vacuum, moisten that, and now we're going to take this. You want to swirl it into suspension from the bottom and then all at once dump. That will get you the most amount out, the cleanest possible, and this will slowly vacuum through. Now there is still some left in here. That's what this is for. We add a little bit of the ice cold water. We don't want to use hot water or warm water because it will redissolve our stuff, and so we only want to use cold water. It looks like we got it all out. We use a little bit more here just to wash away any impurities. Then you're going to come here, turn off the vacuum, take this piece off, put that in your drawer, and you're done.